These are not the jets lined up at air shows behind a fence. Russia built these once, flew them a handful of times, then buried them in a museum outside Moscow. Some killed the crews testing them. One is still classified, by international law, as a boat. This isn't a list of records. It's a list of aircraft built to answer a question nobody else was brave enough to ask. 1. That's the entire production run of the most radical fighter shape Russia ever built. Not 4, not a dozen. One airframe, forward-swept wings bolted onto a borrowed Su-27 fuselage, painted black and rolled out in 1997. That number alone tells you something. It means Sukhoi bet years of composite research and a fortune in post-Soviet rubles on a wing that physics actively fights against. Forward sweep twists itself apart under load unless the material is engineered to resist it. Test pilot Igor Votintsev flew that bet into the air on September 25, 1997, at Mach 1.65, inside an airframe that wanted, structurally, to tear its own wingtips off. It never happened twice. No second Berkut, no production line, no squadron. But the fly-by-wire logic built to keep that unstable shape alive didn't die with it. It went straight into the Su-35 and the Su-57. One airplane, built to fail at its stated job, ended up teaching Russian aviation how to keep a fighter alive when the math says it shouldn't be flying at all. Before the M50 ever left the ground, the fear driving it was simple. America was building supersonic bombers, and the Soviet Union had nothing to answer with. So Myasishchev built one. 4 engines, delta wings, a silhouette designed to make NATO nervous the moment it appeared over Tushino. Then came the flight itself, on October 27, 1959, with test pilots Goryanov and Lipko at the controls. Full afterburner. Every gauge pushed, and the aircraft topped out at Mach 0.99. Not once, across 19 flights, did it break the sound barrier it was built entirely around breaking. Here's what happened after. NATO still panicked, still assigned it the name Bounder, still treated it as a real threat at the 1961 air show. The propaganda victory landed, even though the physics never showed up. And months earlier, during an engine run-up, the M50 had jumped its own wheel chocks and plowed into a parked sister prototype, wrecking it completely. 2 months later, repaired, it flew again. A bomber that never worked kept flying anyway, because looking dangerous had already done its job. Picture the Caspian Sea in the early 1970s. A flat expanse the Soviet Navy needed watched constantly, because somewhere under it, American Polaris submarines could be sitting with nuclear missiles pointed at Soviet cities. No conventional aircraft could loiter there efficiently, and no ship could search fast enough to matter. That gap is what forced the shape of the VVA-14. Part flying boat, part helicopter, part ground effect glider, built to take off vertically from open water and hunt. The limitation bit back immediately. 12 lift engines were supposed to give it true VTOL capability, and the supplier building them simply never delivered. Bartini's team adapted anyway, bolting on inflatable pontoons, then rigid ones, flying it 107 times as an ekranoplan instead of the hunter-killer it was designed to be. Then, in 1974, Bartini died, and the adaptation stopped adapting. No lift engines ever arrived. No submarine was ever found. The aircraft that was built to solve one specific Cold War problem never got the chance to try, and now sits dismantled in a museum outside Moscow, still missing the 12 engines that were the entire point. The problem was simple and terrifying. America was flying the XB-70 Valkyrie at Mach 3, and nothing in the Soviet arsenal could catch it or match it. Sukhoi's answer meant inventing an aircraft skin that could survive sustained triple-sonic heat without melting or crumpling. Aluminum couldn't take it, so engineers turned to titanium and stainless steel, machining and welding metals nobody in Soviet industry had mastered at that scale. The solution generated almost 600 separate patents just to solve the manufacturing problem alone. New tooling, new welds, new alloys built from scratch for one airframe. Here's the cost. Test pilot Vladimir Ilyushin took the finished T-4 into the sky on August 22, 1972, and flew it exactly 10 times, totaling just over 10 hours of flight, before the program was shut down in 1974. Not from failure. From politics, a defense minister traded the entire project away for a fighter jet order. Ilyushin said later that nobody ever explained anything to him and called scrapping 2 half-built prototypes a crime against every mistake still waiting to be found and fixed. How does the largest jet-powered amphibious aircraft in the world take its first flight? Not the way you'd expect. On December 8, 1986, a test crew ran the A-40 through a routine high-speed taxi test on the runway at Taganrog. Full throttle, nose down, never meant to leave the ground. It left the ground anyway. The aircraft became airborne mid-taxi, with a runway rapidly running out beneath it, and the crew had exactly one option left: keep flying, because there wasn't enough tarmac remaining to abort. They took it up, brought it back around, and landed without further incident, saving a 40-meter, 90-ton prototype that could easily have been destroyed in a single unplanned mistake. Here's the drama. That same crew, the ones who improvised a controlled first flight out of what should have been a runway accident, were quietly demoted from their duties afterward. No public credit, no promotion, just a reassignment for turning a near disaster into the maiden flight of a record-setting aircraft nobody had planned to fly that day. One classification changes everything about this machine before you even see it move. The International Maritime Organization doesn't call it an aircraft, it calls it a ship. That's the number that reframes the whole thing. Not a speed, not a weight, but a legal category, assigned because it never climbs more than a few meters above the water. Here's how it actually looks in the real world. 8 turbofans mounted on forward canards drag 380 tons across the Caspian Sea at 340 miles per hour, skimming so low it slips under radar entirely. 6 missile launchers riding down its spine like a warship that happens to be airborne. Now the contrast. It looks, from any distance, like a boat that got out of the water. It flies, physically, on the same aerodynamic lift that keeps a 747 up. It can't climb to escape rough weather, can't function as a plane, can't function as a ship. It exists entirely in the gap between the two, in a strip of physics only a few meters thick, one classification instructing you to see it as something it plainly is not. Here's the fact nobody expects: the world's first supersonic passenger jet, flying before the Concorde, faster than the Concorde, broke apart in midair in front of 250,000 people, live, at the 1973 Paris Air Show. That's the starting point. The cause traces back to pressure, not mechanics. Pilot Mikhail Kozlov had reportedly told people beforehand to just wait and see what his aircraft could do, determined to outperform Concorde's display minutes earlier. He pushed the Tu-144 into a steep climb on full afterburner, past 2,000 feet, then stalled it at low altitude, attempting maneuvers the airframe was never rated for. The left wing tore away outboard of the engines first. The fuselage snapped. Now the consequence, the one that reaches past the wreckage. 6 crew died in the air. 8 more died on the ground in the town of Goussainville, 3 of them children. Houses collapsing under burning debris from a machine that was supposed to prove Soviet supremacy to a watching world. It proved something else instead, that the need to win in public, in that exact moment, can cost more than the contest was ever worth.